Okay, so today we're going to be talking about factoring, and we do a lot of factoring. So this is something that we're going to really focus on and spend a little bit more time getting these basic skills of factoring down so that we can get into more advanced stuff more comfortably. But before we start factoring, let's review a concept. Let's say we're going to multiply a couple binomials together, so x minus 3 and x minus 5. Well, remember, we're going to distribute each term in the first binomial with each term in the second binomial. Okay? I know you're familiar with the FOIL acronym. I'm not a big fan of that because it only works in a very special case, which is a binomial and a binomial. Really, it's what you're doing is using the distributive property. And that FOIL thing breaks down once we throw in trinomials or, you know, anything that has more than two terms. So I want you to view it differently. So we're going to take the x term and we're going to distribute it here both to the x and to the negative 5. So that will yield x squared minus 5x, and now we're going to distribute the negative 3 to both terms. So that's going to be negative 3x plus 15. And we just simplify. Now when we simplify, what we're doing here is these two middle terms we're going to be adding together. So we're going to say plus, and we have a negative 5 and a negative 3 and an x. And the 15, keep in mind how we got the 15 is we multiplied the negative 3 and the negative 5 together. So we said, oh, that's going to be negative 3 times, that's negative 3 times negative 5. So, or negative 5 times negative 3. In any case, let me just switch that around to make it look a little bit more consistent. So that's negative 5 times negative 3. So we have the same terms here, and here we're multiplying them together in the last term of our trinomial, and then the middle term we're adding them together. That's going to play an important role when we start factoring, because we're going to do this process backwards, and this is the key thing is, how do we get this? And so we get x squared plus negative 8x plus 15, or x squared minus 8x plus 15. So now let's go ahead and look at the pattern. So as I said here, when we multiply a binomial and a binomial, we usually end up, or a lot of time we end up with a trinomial, which has three terms. We have our x squared term, and then we have our bx and our c. And see, when we multiply the binomial and binomial, we get that. But likewise, this trinomial is equal to this binomial. And so instead of going, from this to this, when we multiply, we're going to do the opposite and factor into here. Okay? So that's the idea. It's kind of like a basic concept is, let's say I have, 14, and I want to factor 14. It's prime factorization, so we would say, oh, that's going to be 2 times 7. Except here we're doing it with a trinomial and getting a binomial. So like if I had the x squared minus 8x plus 15, I'm saying, oh, what times what gives me this? Oh, well, the first term would be x minus 3, and then the next term is going to be x minus 5. Okay, and so we're just, instead of doing single number factoring, we're doing it with binomials and trinomials. And so, and as we can see here, oh, remember when we multiply it together, the m and an n term, the two constants in our binomial are added together for the middle term and then multiplied together for our constant in our trinomial. So keeping that in mind, we want to factor this expression. So remember, here we're going to multiply m times n together, and here this is m plus n. So we're adding the two terms. And ultimately we're trying to get, okay, it's going to be x plus m and then x plus n. So we need to figure out what m and n are. So a good way of doing that is we're looking for multiples of 48 and that add to 14. So what m and n multiply to 48, which add to give us 14. We could try, let's say, 6 and 8. Okay, well 6 times 8 gives us 48. That's where I'm getting it. But when I add them together, does it give me 14? And well, yes, it does. And these are the terms I'm going to, I want to use. Now you might have to go through several, tries. So let's say, for instance, you tried 48 and times 1. Well, that gives you 48, but if you add it together, it gives you 49 rather. And that's not going to work. It's got to equal the middle term when you add them. So here's my m, here's my n term, and I'm left with x plus 6 and x plus 8. And remember, it goes both ways. So when I factor, that equals these binomials here, but I can multiply these together and that'll give me the trinomial. So the way you check is you multiply it back together and see if, hey, is that the original trinomial I started off with? So I'm going to check this. So I'm going to distribute the x to both terms. So that gives me x squared plus 8x, and now I'm going to distribute the 6x to both terms. So plus 6x plus 48, and I get x squared plus 14x plus 48, and that's what I started off with. So that is indeed my answer. So I box that in. Let's look at another one. One thing I want you to be aware of is the signs when you do this. Before I do that, I know there are like a variety of different methods or gimmicks that you may have learned maybe in Algebra 1 about factoring. But I'm going to be very if you want to use that, that's fine. I'm going to insist that you know how to use this method though, because the factoring we're going to do, a lot of those gimmicks don't work. They start breaking down once we start getting into more complex factoring. So I recommend that you get used to the way that I'm doing it here, so that you will be better off when we do other things. And I know there's this algorithm, like, my father drives a silver Mercedes or something like that. I really don't like that one because you don't know what you're doing there. You're just following a number of steps without understanding what the mathematics is going on behind it. So, and really this is a class about understanding what we're doing. So on that note, let's use that goal of understanding what's going on to help us what's going on with this trinomial to factor it. So, all right, I'm looking for things for this one which add to -5 but add to -9. Okay, so the signs play a difference. Because this term is a -5, if we think about it, that means the two numbers that we're multiplying together have to have different signs. One has to be a positive, one has to be a negative. That's the only way we're going to get a negative. And the second negative here, remember we add the two terms together, so the only way that you can add a positive and a negative term together is that the negative term is greater or more than the positive term, so to speak. I mean, it's not really greater, but if you add them together, you're left with a negative. So whatever the larger number is, that's going to have the negative sign on it, so to speak. So, so 5 is pretty 5 is pretty easy. 5 is a prime number, and the only things that multiply with negative 5 are 5 and 1. And since the larger number is negative, we're only left with the choice of negative 5 and positive 1. If we add that together, well, that leaves us with negative 4, which is clearly not negative 9. And if we try, if we just wanted to try, and this doesn't make sense because we already shown that the larger number has to be negative, but if I just tried negative 1 and 5, that's not going to work because that leaves me with positive 4. So what happens when you get here? Well, it just means that we can't factor. So can't factor. Or in other words, we call it prime. Only 1 in itself will go into it. So you're going to run in cases like that. But if instead of having to guess and check a whole bunch of things and get frustrated like I don't get it, I don't know what it is, I don't know what it is. If you think about it a little bit, I figured that I couldn't factor it within the first within my first try. Okay, but this one was a little bit easier. Sometimes it might take you 2 or 3 chances, but you can eliminate the possibilities really quickly if you look at the signs. So, work with those patterns on the plus and minuses in your trinomial.